Welcome to the Anthropic Claude Certified Architect Foundations, CCA-F Question Bank Series. Here, we review agentic architecture, Claude code, prompt engineering, tool and MCP design, and context management scenarios-related questions you'll see on the real CCA-F exam. In this video, I've got 5 exam-style practice questions lined up for you. Each question comes with the correct answer and a full explanation, including why the wrong options are wrong. Here's how to get the most out of this. When a question appears, pause the video, pick your answer, then hit play to check yourself. Ready? Let's dive in.
Question 66. A team generates marketing copy that must satisfy a detailed brand style guide. First pass output meets the guide roughly 60% of the time, and the failures are usually identifiable against explicit written criteria. What pattern best raises the pass rate? The correct answer is A, an evaluator optimizer loop, where a second call scores the draft against the criteria and returns specific feedback, and the generator revises until the criteria are met or an iteration cap is hit. The evaluator optimizer pattern applies when quality can be judged against explicit criteria and feedback is actionable, exactly the situation described. Separating generation from evaluation lets the critique be specific, and an iteration cap keeps cost bounded. Now, why the other options are wrong? A single call with the style guide appended and a stronger instruction to follow it is incorrect. This is the current approach with more emphasis. It gives the model no opportunity to inspect its own output against the criteria, which is where the improvement comes from. Generating 5 drafts in parallel and returning the first one produced is incorrect. Returning an arbitrary draft ignores quality entirely. Parallel sampling only helps if something selects among the candidates. Fine-tuning a model on the brand style guide text is incorrect. Training on the guide is a heavy, slow investment that still gives no per-draft verification, and the guide will change. Evaluation at inference time is the cheaper and more auditable control. Question 67. An assistant handles 3 very different request types: short factual lookups, long document analysis, and code generation, each best served by a different prompt and model size. What architecture handles this cleanly? The correct answer is B, a routing step that classifies the incoming request and dispatches it to the specialized prompt and model for that category. The routing pattern separates classification from handling, which lets each request type get a prompt and model tuned for it. It also keeps the specialized prompts small and focused, rather than merged into one general prompt. Now, why the other options are wrong? A single large prompt containing the instructions for all 3 request types is incorrect. One combined prompt carries irrelevant instructions on every request, costs more, and gives the model an opportunity to apply the wrong set of rules. Running all 3 specialized handlers on every request and returning the longest answer is incorrect. This triples cost on every request, and answer length is unrelated to which handler was appropriate. Asking the user to choose the request type before submitting is incorrect. Pushing classification onto the user adds friction and will often be answered wrong. The system can determine this reliably. Question 68. A 3-step pipeline extracts data, transforms it, then writes it to a system of record. Occasionally, a bad extraction propagates and corrupts downstream records. What is the most appropriate design change? The correct answer is C. Insert a deterministic validation gate after the extraction step that rejects or quarantines output failing schema and business rules before the transform runs. In a chained pipeline, each handoff is the natural place to validate. A gate that checks schema and business rules after extraction stops bad data at the boundary instead of letting it reach the system of record. Now, why the other options are wrong? Combine all 3 steps into one prompt so there are fewer places to fail is incorrect. Merging the steps removes the inspection points rather than adding one and makes it harder to tell which stage produced a bad result. Add a rollback procedure that reverses corrupted writes after the fact is incorrect. Rollback is a useful safety net, but is recovery, not prevention, and reversing writes to a system of record is often messy or impossible. Ask the model at the final step to double-check that the extraction looked correct is incorrect. A self-check at the end is a soft control at the wrong point, and it asks the model to validate work whose source material it may no longer have. Question 69. An agent writes and executes Python to analyze user-uploaded data files. The team is concerned about what that generated code could do to the host. What is the appropriate control? The correct answer is D. Execute the generated code in an isolated sandbox with no credentials, a restricted file system, and no or tightly limited network egress. Generated code should be treated as untrusted and executed under isolation. No ambient credentials to steal, a file system scoped to the task, and constrained egress so it cannot exfiltrate data or reach internal services. Now, why the other options are wrong. Scan the generated code with a regular expression block list for dangerous calls before running it is incorrect. Pattern block lists are trivially bypassed by equivalent constructs and dynamic evaluation. They add friction without providing a real boundary. Instruct the model in the system prompt to write only safe code that touches nothing outside the task is incorrect. This relies on the model's cooperation for a security property. Prompt injected or simply careless code would still execute with full host access. Review each generated script manually before it runs is incorrect. Human review is a reasonable additional control but does not scale to an interactive agent, and reviewers miss subtle issues. It is not a substitute for isolation. Question 70. An agent calls a log search tool that sometimes returns 200,000 tokens of matching lines, which blows the context window and fails the request. What is the best design change? The correct answer is A. Have the tool paginate and cap its response, returning a summary with counts plus the top matches and a token for fetching more. The fix belongs in the tool contract. Capping the payload and returning aggregate counts with the most relevant matches keeps every response bounded, and a continuation token preserves the agent's ability to dig further when it needs to. Now, why the other options are wrong? Truncate the tool result to the first 5,000 tokens before passing it to the model is incorrect. A blind head truncation is better than failing, but it silently discards possibly relevant matches and tells the model nothing about what was dropped. Move to a model with a larger context window is incorrect. This raises the ceiling without bounding the payload, so a larger search still overflows, and every request now costs more. Instruct the model to write narrower log queries is incorrect. Helpful guidance, but the tool must still behave safely when a query legitimately matches a great deal. The contract needs the bound.
And that's a wrap on this video. Nice work getting through those 5 questions. If this helped, you're going to want the complete set. All 390 exam-style questions, with full explanations across all 5 CCA-F domains, are available in my Udemy course, Anthropic Claude Certified Architect, Foundations, CCA-F. 6 full practice exams. The link is in the description below. Make sure you subscribe so you don't miss the next video, where I'll walk you through 5 more questions. See you in the next video.